Hello friends, in this question we have to find the characteristic equation of AB flip-flop, okay, whose truth table is given to us. Okay, so let us see how to proceed. So here Qn is your present output, okay, present output, and Qn plus 1 will be the future output, okay, or you can say state. Okay, so here your future output or your future state is going to depend on is a function of a, b, and your present output, okay, whatever is your present output. Okay, so now we need to find the expression of this Qn plus 1. Okay, so that's what the question says. Okay, so let us see how to proceed. So what we gonna do is we'll make a truth table. Okay, here already a truth table is given to us, but this is not an expanded form. So we'll make a truth table in expanded form and then try to find our Qn plus 1 expression. Okay, so Qn, A and B, okay, these are in a way you can say inputs, and Qn plus 1 is your output. Okay, now this present output and A and B can have 8 combinations, so let us write down those 8 combinations. Okay, so it will be 0 0 0 0 0 1, okay, 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, now let us also write down the decimal equivalent of these. Okay, this will be corresponding to 0, this is 1, okay, so on up to 7. So 2 3 4 5 6, okay, 7. So here we have now our truth table. Okay, uh, and just we need to see what our Qn plus 1 is going to be. Okay, so that we will do with the help of the truth table which is given to us. Now let us say, let us pick up the case of a and b both being 0. Okay, so here it says just when a and b are both 0, your Qn plus 1 is always going to be 0. So you have two such cases, 0 0 and 0, and 0 0 and 1. Okay, so in both cases your Qn plus 1 should be 0. Okay, so it is 0. Now you say your a and b are 0 and 1. Okay, so there again we have two cases. Okay, 0 and 1 and 0 and 1. Okay, so in that case also your output is going to be Qn bar. Okay, so you can see here that in the first case your Qn is 0, so the output should be 1, the complement of that. Here also 0 0 1, and input is 1, so output should be 0. Okay, now let's take the third case where your input is 1 0. Okay, a and b are 1 and 0 respectively, so your output is simply what your input is. Okay, or your present input output is. So here it is 0, so your output, again your future output is going to be 0. Here it is 1, so your output is also going to be 1. And in the last case when it is 1 1, your Qn plus 1 is always going to be 1, whatever it be your Qn. So your Qn in this case is 0, so your output but will be 1, and here also it will be 1. So now you have your complete truth table here. Okay, when once you get a complete truth table, what you need to do is you need to use Karnaugh map and you need to reduce. Okay, and find an expression. Okay, so let us now make a Karnaugh map here. So this Karnaugh map, okay, here I put my Qn, okay, and here I put a and b. Okay, so this Qn can be Qn bar and Qn. Okay, and here your AB will be a bar, b bar, a bar, b, ab, and ab bar. Okay, okay, so what I will do is I will just write the decimal equivalent also, so that it becomes easy. So it is 0 1, it will be 2, it will be 3, 4, 5, 6, and 7. Now let us say which cases we get 1. So we get 1 for this 1, okay, for 3, okay, for 6 and 7. So 1 3 6 and 7. So you can see here that now we can, for reducing we can form pairs. So there is one pair here, okay, and one pair here, okay. So my qn plus 1 is simply going to be, you can see what's common here, it is qn bar, okay, and here the common is, you can see b, so we'll write b, okay, plus, you can see in this line the common is qn, okay. This is how you need to write, okay, for pair. And here you see common is a, because b is going from b to b bar, okay, so only a is common, so a, will write a. Or you can simply write qn plus 1 is equal to a qn plus um, plus b qn bar, okay, b qn bar, okay. Now you can see it matches with option b, okay. So option b is the correct answer for this question, okay. So this is how you can proceed for these kinds of question. So thanks for watching.